Okay, welcome to another video on integration. This is about rules, trigonometry, and exponents. Let's start solving some questions. A lot of these questions will have trigonometric identities. Let's solve. The first one says prove the identity this. Now, proving the identity, we've learned that we could prove either the left hand side or the right hand side. The right hand side is easier. Why? Because I can use an identity for cos 4 theta, and remember that cos 4 theta can be replaced with 2 cos square 2 theta minus 1, or it can also be replaced with 1 minus 2 sine square 2 theta. Now in my classes I've told you that always use the identity that gets rid of the 1 if you have an identity for cos, a double angle of cos. So I am going to do that. I'm going to say that this can be replaced with 1 minus 2 sine square 2 theta. That will help me get rid of the 1. How will it help me get rid of the 1? This becomes 1 minus 1 plus 2 sine square 2 theta. So the 1 cancels out. I'm left with 2 sine square theta. The 2 also cancels out with a 4. So I have 1 over 4 sine square 2 theta. Now I don't need sine square 2 theta. I don't need sine 2 theta. I need sine theta and cos theta, which means that I again need to use an identity and say that 2 sine theta cos theta whole square. Okay, that gives me 1 over 4 and 4 sine square theta cos square theta, and I think that proves my identity, sine square theta plus sine square theta into cos square theta. Then in part 2 the question is asking you to integrate this, and I think that's relatively simple. I don't integrate this. Instead I integrate 1 over 8 1 minus cos 4 theta. The easier thing to do is pull out 1 over 8 common and say that this is 1 minus cos 4 theta. So this becomes 1 over 8 theta minus sine 4 theta over 4 with the limits 0 to pi over 3. So 1 over 8 pi over 3 minus sine 4 pi over 3 over 4 brackets 0 minus sine of 0 over 4. So I think that's pretty simple. What's sine 4 pi over 3? Let's use a calculator to find that. That gives me minus root 3 over 2, so that adds up to 1 over 8 pi over 3 plus root 3 over 8, and I think that is the correct answer. I can see the answer here and it matches my numbers. So pi over 24 plus root 3 over 64. That's the first question. Moving on to the second question quickly. Again, it says prove the identity. So I'm going to start proving the identity. I'm using the left hand side again because it's easier and I need everything in terms of sine. So I'm going to say that this becomes 1 minus 2 sine square 2 theta. Cos 4 theta becomes that. And minus 4. 1 minus 2 sine square theta plus 3. Okay. Then I have if I open up the bracket, 1 minus 2 sine square 2 theta minus 4 plus 8 sine square theta plus 3. Now to expand sine 2 theta, I need to pull out the square first. I can add the other numbers up. Let's quickly add the other numbers up. That's 1 minus 4, that's minus 3. So I think all the numbers cancel out. 1 plus 3 and minus 4. So I have minus 2, and this becomes 2 sine theta cos theta whole square plus 8 sine square theta. That gives me 4 sine square theta cos square theta plus 8 sine square theta. Now I don't need cos theta, so I'm going to again change that to 1 minus sine square theta. And multiplying all of these gives me minus 8 sine square theta plus 8 sine power 4 theta plus 8 sine square theta. And I think I have my answer there. This cancels out, and therefore that is the correct answer. Then it says using this result, find in simplified form the exact value of this. Now I know from my lecture that I cannot integrate powers of trigonometry till I have a situation that gets rid of the power. So that's what I'm going to do. I know that sine power 4 theta can be replaced with 8 in the denominator and with this, the other side of the identity, plus 3 divided by 8. I can pull out an 1 over 8 common and I can start integrating. So cos 4 theta, let's just write that first because I've written an integral sign, and then I'm going to plug in the limits as well. So I have 1 over 8 sine 4 theta over 4, 4 sine 2 theta over 2 plus 3 theta, from pi over 6 to pi over 3. So I'll need a bit of space. I'm using this space down here. Okay. Unlikely that I'm going to be able to write that. Okay, 1 over 8 sine 4 pi over 3 over 4. That's 2 sine 2 pi over 3 plus 3 pi over 3. That's the lower limit. I think I still need more space. Minus sine 4 pi over 6 over 4 minus 2 sine 2 pi over 6 plus 3 pi over 6. Okay, I will do everything on a calculator and tell you that this is 1 over 8 minus root 3 over 8 that's root 3, and that's pi. Then I have root 3 over 8 2 pi over 6. So that's root 3, and that's going to be plus root 3 and plus pi over 2 minus pi over 2. Okay, so this cancels out with that. No, it doesn't cancel out, it adds up. The root 3 cancels out. So I have 1 over 8, pi minus pi over 2 is pi over 2 minus 2 root 3 over 8. So that is pi over 16 minus root 3 over 32. Taking common denominator, that's 2 pi minus root 3, and I think I have my answer there. So that's 2 pi minus root 3 over 32. Going on to the next question, again it's just prove that identity. I start proving. I remember that cos 3 theta cannot be done directly. You break it up into this and then you use compound angles. You say that cos 2 theta cos theta minus sine 2 theta sine theta. So I have 2 cos square theta minus 1. I need everything in terms of cos theta, so that's what I'm going to do. 2 sine theta cos theta into sine theta. So that gives me 2 cos cube theta minus cos theta and 2 sine square theta cos theta. So 2 cos cube theta minus cos theta minus 2 1 minus cos square theta into cos theta. 2 cos cube theta minus cos theta. It gives me 2 into 1 into cos theta gives me minus 2 cos theta, and 2 into cos square into cos theta gives me plus 2 cos cube theta. So that's 4 cos cube theta minus 3 cos theta. And I hope that's the correct answer. Yes. Using this result, find the exact value of that. So I am going to use this result. Now I know that I cannot integrate cos cube theta, which means that I must replace it with something. The only way of doing this is to take this to the other side and say that this identity can have a different form, and say that cos cube theta can be replaced with this cos 3 theta plus 3 cos theta over 4. And then put in the limits after integrating. So I have cos cube theta. I will first replace it with cos 3 theta plus 3 cos theta over 4. I will pull out a 1 over 4 common and start integrating. So I have 1 over 4 sine 3 theta over 3 plus 3 sine theta. And the limits are pi over 3 and pi over 2. So inserting the limits, sine 3 pi over 2 over 3 plus 3 sine pi over 2 minus sine 3 pi over 3 over 3 plus 3 sine pi over 3. Okay, let's evaluate this. Sine 3 pi over 2 will give me, sine of 270 should give me minus 1, I think. Yeah, minus 1, so minus 1/3, and this pi over 2, so that gives me plus 3 minus sine 3 pi over 3 will give me 0, and 3 sine pi over 3, sine pi over 3 is root 3 over 2, give me minus 3 root 3 over 2. Okay, adding these up, and 3 minus 1/3 is 8/3. So 1/4 into 8/3 minus 3 root 3 over 2, multiplying them by 1/4 gives me 2/3 minus 3 root 3 over 8. That is the correct answer. Moving on to the next question quickly. This one is about both differentiation and integration. The diagram shows a curve this and its maximum point M. The x-coordinate of M is denoted by P. Find the exact value of P. So y equals to e power minus x minus e power minus 2x. So dy by dx would be e power minus x into minus 1 minus e power minus 2x into minus 2. That gives me minus e power minus x plus 2 e power minus 2x. That is equals to 0. So solving this, if I can make it simple, pulling this to one side, I can subtract the powers. E power minus x minus minus 2x equals to 2. So that gives me e power minus x plus 2x, which gives me, so x equals to ln 2. That's the answer to the first part, which is the exact value of P. So I found out P. Next part says show that the area of the shaded region bounded by the curve, the x-axis, and the line 0 to P is equals to 1 over 8. So in this case P should be ln 2. I integrate this, and I think it's a simple integration. So e power minus x divided by minus 1 minus e power 2 minus 2x divided by minus 2. I integrate this from 0 to ln 2 minus e minus ln 2 plus e minus 2 ln 2 over 2 minus e power 0 over minus 1 plus e power 0 over 2. So minus e power minus ln 2 should give me minus half. I'm putting this on my calculator. I am not doing this manually, remember that. Although I could do it manually by cancelling e and ln, but that would involve, changing the powers and everything. So it's better just to do it on a calculator. So the other one becomes divided by 2. Uh, 2 gives me 1 over 8. And I get plus 1 from here and minus half. So minus half, and 1 cancel out. 1 over 8 should be my final answer, and that's true. Question number 5 is about cos x over 1 plus sin x. Show that f bar of x is less than 0 for all x in the interval this. So I am going to find out f bar of x first. This is the quotient rule. So I'm going to say that u equals to cos x, v equals to 1 plus sin x. U dash is sin x with a negative, v dash is cos x. So u dash v minus v dash u over v squared. So minus sin x minus sin squared x minus cos squared x pulling out a negative common gives me sin x plus sin squared x plus cos squared x. Now I remember from my identities that sin squared x plus cos squared x is 1. Yeah, let's randomly scroll down. So sin x plus 1, and the denominator is 1 plus sin x whole square, which means that I can cancel one of these out and say that this bracket cancels out with 1 power of the bracket, and I'm left with minus 1 in the numerator and 1 plus sin x in the denominator. What I had to prove to you is that it is less than 0, which means that it is negative for all x in the interval. Now if I notice this expression that I have, the numerator is always negative and denominator is always positive, because sin x is always between minus 1 and 1 in that interval. It can be equals to 1, but it never reaches minus 1, so it never reaches 0 for that matter, because this is telling you from minus 90 to 270. Okay, so if I remember the curve from minus 90 to 270, the 270 value isn't included. It's not included if you see this, and if I go down to minus 90, it also stops here. So minus 1 is not included, 1 is included. Therefore sin x keeps fluctuating between 1 and minus 1, so it never becomes negative if the numerator is negative and the denominator is positive. Overall f bar of x is always negative. That's the first thing I have proved to you. Then says find this, giving your answer in simplified exact form. Now to integrate this, remember that we have studied something called integration by recognition. I recognize that the differential of the denominator is appearing in the numerator, so this can simply become ln 1 plus sin x, because I've recognized that the denominator's differential is in the numerator. If you don't remember this, please go back and study integration by recognition. So I have then keeps randomly scrolling back. I don't know what the issue is. Okay. I have the limits pi over 6 and pi over 2. So ln 1 plus sine pi over 6, pi over 2 first, minus ln 1 plus, sorry for that, uh, ln 2 minus ln 3 over 2. So ln 2 divided by 3 over 2. Yeah, that is the correct answer. Ln 4 over 3. Moving on to the next question quickly. Question number 6. The diagram shows a curve. The x-coordinate of the maximum point is alpha and the shaded region is enclosed by the curve. The lines in this show that alpha equals to 2/3 y. So this is about differentiating and finding out the maximum point. So I'm going to differentiate and say that it is 8 cos half x into half minus sec square half x into half. So I get 4 cos half x minus half sec square half x. Now there's nothing common. I have to equate this to 0. I'm going to first bring this to this side and say that this becomes this. I don't know how to solve sec square x, so I'm going to say that this becomes 1 over cos square and this 2 gets multiplied, so 1 over cos square half x equals to 8 cos half x. Now I see that I have half x on both sides, so I am going to say that 1 over 8 comes here and this becomes cos cube half x, and then taking a cube root on both sides I get 1 over 2 cos half x. Then I mark my quadrants, although this is just quadrant 1 that I can have my answer in, but since this is half x, I did even half of that. Quadrant 1, alpha is equals to cos inverse of half, which is pi over 3. So half x equals to pi over 3, x equals to 2 pi over 3. Then part 2 says find the exact value of the shaded region. So I'm going to integrate from 0 to 2 pi over 3. Okay, so 8 sine half x integrates to 8 minus 8 cos half x over half, and tan integrates to minus ln cos half x. This is from integration by recognition, although we learn it, it's easier to remember it rather than derive it every time. So 0 to 2 pi over 3. So the integration of tan x is minus ln cos x. So in this case I have half x, so I divide by half at the end. This becomes minus 16 cos half x plus 2 ln cos half x. And I have the limits 0 to 2 pi over 3 minus 16 cos 2 pi over 6 plus 2 ln cos 2 pi over 6 minus 16 cos of 0 plus 2 ln cos of 0. 16 into half plus 2l1/2 minus 16, cos of 1 is minus 16, and then 0. So that gives me this is a minus 16, so this should be a plus 16. 16 minus 8 gives me 8 plus 2l1/2, and that is my final answer. Moving on to the next question, I have this. I have to first prove the identity to you. So I'm going to use the left hand side in this case because it's going to be difficult to break the right hand side. I have sine theta over cos theta plus cos theta, cos theta over sine theta plus sine theta over cos theta. So I have sine theta cos theta in the denominator. This becomes cos square theta because it gets multiplied with cos theta that was in the other denominator, and this becomes sine square theta because of taking an LCM as I did with the other cos square theta. This becomes 1 over sine theta cos theta. Now again, if I remember my identity for sine 2 theta, it's 2 sine theta cos theta. So that gives me sine theta cos theta equals to sine 2 theta over 2. So this is sine 2 theta over 2. That gives me 2 over sine 2 theta. I take the reciprocal, then sine 2 theta in the denominator is basically cosec 2 theta. So that was simple. Then it says integrate what? Cosec 2 theta. I don't know the integration of cosec 2 theta at all. So what I'm going to do is I'm going to replace this with, since it says hence, I'm going to replace this with this and say that I know the integration of cot theta, and the integration of cot theta is ln sine theta, and the integration of tan theta, which we just did in the previous question, is minus ln cos theta. And the limits are pi over 6 to pi over 3. So I could write it simply as sine theta over cos theta and make it easier for myself. I know that the limits are there, pi over 6, pi over 3. This is indeed ln tan theta. That makes it even easier. So ln tan pi over 3 minus ln tan pi over 6. Let's see what tan pi over 3 is. So ln root 3 minus ln root 3 over 3. So these again get divided. I must have missed something while I was calculating. Oh, I've missed this 2 here. So there should be a half outside. There should be 2 and then there should be a half outside, which is why my answer is not the same as in the one in the question. So root 3 multiplied by 3 over root 3. So that gives me half ln 3. And that is indeed the required answer. Moving on to question 8 quickly, it says prove the identity. So I'm going to quickly try to prove it for you. Again, I want to get cosec 2x, so I'm going to go with cos x over sin x minus cos x over cos 2x over sin 2x. I can't take an LCM right now because I need both of these to be standard in terms of what I can take an LCM with. I'm going to write this as 2 cos square x minus 1 just as a hunch because I don't know what I have to do with this. So that gives me a denominator which is indeed sin 2x. This gets multiplied with 2 cos x, so this becomes 2 cos square x, and luckily for me this also cancels this out. So I get 1 over 2 sine x cos x, which is again sine 2x in the denominator, which is cosec 2x. Yep, that is indeed the correct answer. Then it says integrate this. So I know that the integration of cot x is simple. It is ln sine x. I have to remember that this is derived from integration by recognition. If you want to know how it's derived, please go back and watch the video on integration by recognition, and that should give you a fair idea of what's going on. Ln pi over 4 minus ln sine pi over 6. So ln pi over 4 is root 2 over 2, and ln sine pi over 6 is half. So ln root 2 over 2 divided by half is simply ln root 2 over 2 multiplied by 2 over 1, which is ln root 2. And this is just asking you to pull the power half out common. So half ln 2. Then it says integrate this. Find the exact value, giving your answer in the form a ln b. So I'm going to do the exact same thing that I just did, and instead of cosec 2x, I'm going to integrate this left hand side. No coefficient this time, so I have to be absolutely sure. If I want to integrate cosec 2x in the third part, I'm going to write cot x minus cot 2x. This becomes ln sin x minus ln sin 2x over 2. The limits are from, again, pi over 6 to pi over 4. Okay, so ln sin pi over 4 minus ln sin 2 pi over 4 over 2, ln sin pi over 6 minus ln sin 2 pi over 6 over 2. Ln root 2 over 2, that gives me sin pi over 2 is 1, so ln 1 is 0, so that gives me 0. Ln sin pi over 6 will give me ln half, and then this is root 3 over 2 ln root 3 over 2 over 2. Okay, this is a little complicated. What is my final answer? Giving an answer in the form 1 over 4 ln 3. Okay, I just want to be absolutely sure that I've solved all of these correctly. Yeah, I have. Okay, I want to express them as common logarithms, so I'm going to say that I have ln root 2 minus ln 2. I'm breaking up the logarithm, and then I have minus ln 1 minus ln 2. Okay, let me just write that here so that it's not confusing. Ln root 2 minus ln 2, the 0 is useless. This becomes minus ln 1, and since minus ln 1 minus ln 2, and this becomes half ln root 3 minus ln 2. Solving this further gives me half ln 2 minus ln 2 minus 0 plus ln 2 plus half ln root 3 minus half ln 2. I see some things cancelling out, so I'm left with half ln root 3, which is half ln 3 power half 1/4 ln 3. Okay, yes, that was the correct answer. Let's look at this next one. Express this in the form that, so I know that r can be found by just taking the coefficients. We've done this in trigonometry. That gives me 2, and alpha is tan inverse of b over a root 3 over 1, which gives me pi over 3. So my expression is basically 2 cos theta minus pi over 3 for part 1. For part 2 it says hence show that this. So if I notice, I can replace this with 2 cos theta minus pi over 3 squared. I know that cos squared is basically sec, so this gets replaced with sec square theta minus pi over 3 over 2, and then I can simply integrate it and say that sec square integrates to tan theta minus pi over 3, and then I have my limits, which are 0 to half pi. Okay, half tan pi over 2 minus pi over 3 minus tan 0 minus pi over 3. Calculating these quickly, pi over 6, tan of answer is root 3 over 3, and tan of minus pi over 3 is minus root 3. So I have root 3 over 6 plus root 3 over 2, and that should give me to root 3 over 3. I hope that's the correct answer. It gives me 1 over root 3. I think I may have made an error there. There is an error with the 2 because there was a half outside. I missed the half. No, I've not missed the half. There is some other error. Let me just look into that. Okay, I have forgotten to square this. This was 4, not 2. This was 4, 4, 4. So this here should give me 12 and 4. Okay, let's do this again in the end. I have root 3 over 3 plus root 3 divided by 4. So I get root 3 over 3. Now you might be thinking that I don't have 1 over root 3. This is the rationalized form. If I want a root 3 in the denominator, I'm just going to say that I multiplied both in the denominator and in the numerator. In the numerator, this gives me 3 and this gives me 3 root 3. So I've proved to you that this is the same. Moving on to the last question quickly. This says the diagram shows the curve this and its maximum point M. The shaded region R is enclosed by the curve. The x-axis and the line is this. Find the exact value of the x-coordinate of M. This is in fact a question that I have already solved in the lecture series. If you are confused, please go back and watch this question from there. Thank you for watching. Please like, share, and subscribe for more videos.